My name's John Trumble. I work at the University of California at Riverside, and the focus of my research for the psyllid, as far as this particular presentation goes, has been on resistance development in some of the key pesticides. Most of our work has focused on imidacloprid, which is Admire Pro. What we have done is we've looked at the Admire Pro and Platinum and determined which ones last longer in the soil and which ones accumulate more in the foliage of the plants. And so far we found that imidacloprid lasts longer. It does not wash out of the soil as quickly as Platinum does, as thiamethoxam. And it has higher concentrations in the foliage. That's the good news. The bad news is that resistance appears to be developing. We have now approximately 2.5 times the nymphal resistance that we've had 6 years ago. 2.5 times resistance does not seem like a lot sometimes, but it actually is in this particular case. Not only does the amount of material have to be much higher in order to bring some control, but the control takes a lot longer. Instead of having control in 1 or 2 days with imidacloprid, we now have maybe 70% control after 10 days. And with that situation, you have the potential for transmission of the pathogen at a very high level. And so our fields this year, we've discovered, are very heavily infested with Zebra Chip pathogen. And that's because the nymphs are simply not dying, and the adults are producing eggs that have very high levels of infection in the resulting nymphs. So this is a real concern for us. We were interested to find out if it goes beyond just the nymphal mortality, because our previous studies had shown that there is a behavioral resistance as well, that the adults, when they land on these plants, would start to feed and then leave. So we tested that particular item as well and found that in fact they don't. They not only are perfectly willing to accept these plants, we can't even get a dose effect from our colonies from Texas. So anything that's come from Texas not only has a nymphal resistance, but it's lost its behavioral resistance as well, and so it doesn't seem to be working. This is not necessarily the case in California. In California, we put on a lot less material as a rule, and we end up with less resistance development. However, we have a huge tomato crop there. In excess of 32,000 acres are being treated now with Platinum and with imidacloprid, about 14,000 or 15,000 with imidacloprid. And as a result, we anticipate that resistance will likely develop if there's a lot of intercrop movement between these crops with this pest. So our long-term concern is that we're going to lose the neonicotinoids, particularly these two that have proven so effective in the past. And we're very concerned that once resistance develops, we may not be able to get susceptibility back. We had some studies that we conducted back in 2006, and we found that there was an LC50, a lethal concentration that would kill 50% of the population at about 20 micrograms per gram of leaf material. And we repeated that work in 2012, and we found that it's still 20. And this is for a population that was not treated with pesticides. As a result, it appears that once resistance develops in these populations, it will be very slow to decline back to a susceptible level. We're also very concerned that the excessive levels that we're hearing for treatment in Mexico may be developing even higher levels of resistance, and the result is that we're not going to see susceptibles coming into the population that may bring down the resistance level. We'll see more resistant insects coming in that will actually increase the resistance level. And if that's the case, we may be losing this entire class of really useful compounds across the country.